Welcome back, Generals, to another Let's Fix Generals 0 hour to make the best game ever. And we are back with unassemblize. Last session, we did, what did we do? Yeah, we looked at this Chromium stack container header, tried to make it compile. Yeah, I think there was a compile error. Left, yeah, here. No appropriate default constructor. Stack allocate. Right, I think we said stack allocate inquiry. Common, wait. So in common types, right, so right now we have this thing here. Stack, yeah. Okay, so how about we remove these guys? No. Let's search for this guy here. Yeah. And common types. Well, actually, let's include it here. Stack container. Common types. Stack container. So let's say we put here a stack string, yeah? This. And then what? Huh. Buff.container. So what does this guy contain? Stack container. Reserve. Let's see how that looks then. I'm a bit suspicious about this thing. Let's see. So I also do wonder. So we have this boof and we pass it in here. Yeah, okay. For now, let's just put this everywhere. Stack string. To me, it looks like a really bad plan. It looks like a bad plan because like how do we access this? So boof.container and then you access it. Like that's not convenient at all. Maybe there should be a stack container. Why? Oh. Nicer syntax. Oof. It kind of, it is misleading, isn't it? I mean, what we could do is we could have a cast operator like this. Right. Then we remove this pointer crap. Like, what would speak against this? Let me see. So now we could say boof.assign. No? Oh no. Hmm. Well, that's bad. Stack. Oh my gosh. Okay, yeah, okay, that's a bad idea as well. Okay, so the best we can do here is like at this point assign something like this. Oof. It's strange because if you have like this construct, then it's totally misleading because then you need to write it like this, which is super misleading. I don't like this. That's pretty bad. Okay, but yeah, let's put a breakpoint in here and see. Oh, no, now we get a lot of, oh boy. No copies already base class. Oh, I see. Okay, then we can remove this here. Yeah, but this still won't compile because, yeah, we can't. We would have to change all the. Okay. Let's put this back to std string for now. Yeah. Stack string. Okay, so how about let's put here a stack string. Call it boof2. And okay, so my suspicion is now that this thing will over allocate. So move 2 steps in here. And so basically we have here the stack capacity. And it will reserve. And now it has reserved 1039. And our allocator, can we see? Used stack buffer, false. Yeah. The stack container doesn't work. In Chromium it doesn't work. Oh my god. These goddamn noobs. Maybe it works on some platforms. Like maybe the author tested it on some platform where the SCD string behaves differently. But with MSVC, the string doesn't behave nicely for this kind of action. Yeah. Okay, I don't think we can use it. I mean, this totally defeats the purpose, right? So yeah, we have an allocator, use stack buffer, false. Can we perhaps really use stack buffer false? Wait, used stack buffer. Where's the set? Allocate. Huh. Okay. Yeah. So it never uses a stack buffer. It goes straight here because n will be larger than the stack capacity because of how the STD string grows. To me, this actually also looks like a problem of STD string, to be fair. Like, how can it be that when you say on a freshly created string, how can it be that if you reserve for a number, that it reserves larger than this number? Like, to me, this is like really bad behavior. Like really, because it's unpredictable. Like you want to reserve for 1024 and it reserves for 15 more than that for no reason, right? There's no rationale why this should be like this. It's just because the implementation is just weird, right? So yeah, I think that this SCD string, the growth of the memory, I think that the choice is bad, that the way they implemented it is bad. But I suspect it's MSVC specific, the way they grow it. Like other implementations may grow differently, right? Yeah. Okay, so this doesn't work. Stack string doesn't work for our purposes. Yeah. Yeah, then we need to look for some. How about we search for C++ stack string implementation? Observe a string using a strict stack implementation. Fast string. Let's see. Fast string. Fast in-stack fixed size string implementation with const expr no except constructors. Fast string. Memory locality and latency. Okay, let's see. Memory for strings not qualified for SSO and reduces memory locality. Fast string is a thin wrapper around a plain char array with const expr no except constructors and accessors for fast in-stack string manipulation. Fast string is a fast and efficient alternative for std string and plain char arrays and low latency applications. Can be used with string view. C++ compatible compiler. Oh, why C++ 20? Const explicitly copy is required. Yeah, but I do wonder. Fast string, const expr. But I do wonder, does this string have a fallback? I mean, fixed size, it's of no good use if it has no fallback. I mean, a fixed string, it makes sense. Like if you really want to clamp it, right? Then I think it's perfectly fine. But I would also like to have a mode where I can say I want it to grow if it does actually need more space, right? Just in case. Fast string. So fast string is really fixed size. Yeah. And C++ 20. Okay. Let's keep on searching. STD stack. What is that? Container. Fast. Is there any references to other ones? No. How about we search C++ stack string. There we go. Stack string list stack. Reverse a string using stack. I'm mostly interested in a stack string that has a fallback allocation. Okay, but we can C++ fixed string. The basic fixed string. What is this? Huh. Okay. This would be nice, yeah. But I guess this one is also without fallback allocation. Read only. We could also try to use string with a static storage allocator, but this solution does not meet structural type requirements. C++ 17 string with fixed. Huh. No dynamic allocations. Okay, so here we have another fixed string, but that one is for C++ 17. Yeah. Okay. Okay, how about we search for fixed string with fallback allocation. Stack allocated fixed. Okay, what is this? Okay, let's see, useless. Fixed size string buffer. Pre-allocated ring buffer. What? Fixed size string buffer. Char array size at compile. The queue stores string messages in a char ring buffer. Older strings are deleted to make way for the new entries. What the hell? What is that used for? Okay. Fixed size circular buffer with automatic overrides. Well, is not something we need. Man. I do wonder, this string here, is it clamped or not? By the way, before we continue here, there's also, I wanted to take some notes here, some to-dos. So we have a background window. I would like to note here, to do, make the background dockable somehow. I think there is a sample somewhere here. Dock space. Dock space. But I don't know how it's used. Ah, here. Okay, so you can somehow dock this, but you can't dock this one. So for some reason we can dock this to the background. Well, can we undock it again? I don't know. How do we undock it? Okay, now it's undocked. Okay, it's kind of weird that it's more experimentation, I guess. Examples, dock space. Make the dockable somehow. There is an example. There's a demo. There's a example in GUI demo examples doc space, examples doc space. Yeah, and there was another thing, right? That's more like a global thing. To do at tooltip markers to fields and buttons that need it. It's a bit very unexplicit. So here we would need one, maybe here, maybe on the filter. Yeah, I think it's fine for now here. Yeah. Good. Okay, back to this guy. Starts with, ends with. That's nice. Ends with, contains. Has a lot of function hash. It looks like a nice string. Okay, hold on. So let's say we assign. There should be a assign somewhere, right? Assign. No? What about append? What the hell? Can't append? What? The hell is that? Oh, so it's just a const export thing. Oh. I see. So it's not for writing. It's just a compile time string with some fancy functions. That's it. Well, that's not what we need. That's not what we need. That is unfortunate. Const expra. Yeah, but this is not what we look for. I mean, there are probably use cases for this, but we don't need this. We need a runtime string that's on the stack. Okay, so this one doesn't help. This one also doesn't help. Oh boy, that's unfortunate. Here we have a stack overflow. Allocates on the stack, yeah. Small string. Small string. Small string is a subclass of small vector. Okay, text string res. Small string avoids allocated memory in the case when the pre-allocated space is enough to hold its data. Very good. And it calls back to general heap allocation when required. Very good. Since it owns its data, it is very safe to use and supports full mutation of the string. Very good. Like small vectors, the big downside to small string is their size of. Yeah, that's okay. Where they're optimized for small strings, they themselves are not particularly small. Yeah. This means that they were great for temporary scratch buffers, yes, but should not generally be put into the heap. Yeah. It is very rare to see a small string as a member of a frequently allocated heap data structure. Yeah, that makes sense. Okay, let's take a look at the small string then. Let's search for LLVM small string. Can we just copy this, or will it have thousands of dependencies? Uh-oh. It has a dependency to small vector storage. Yeah. Okay, dependency on small vector. Let's search for... Probably someone already did this. C++ small string. Like a small... A standalone small string, right? GitHub small containers. Let's see. What is this? C++ small containers. Okay, what is this? Oh boy, stop it. Small vector, small string, small set. Huh. Wow, has a lot. Wow. Wow. Okay, this small vector includes inline allocation for small vectors. Inline? What does that mean, inline allocation? Probably means like a buffer. Custom expected size, special treatment for relocatable types. Relocatable types can be moved with mem copy by passing constructors, destructors. Better growth factors, okay. Consider the cache line size and allocations. Heap allocations can be disabled. Ah, max size vector. Max size. Heap allocations can be disabled. So they're very versatile. You can use them as something that can grow beyond the buffer, or you can disable it again, and that's cool. I like that. When there are a few elements in a given threshold, the elements are kept in a stacked buffer for small vectors. Otherwise, the vector works as usual. If you're 100% sure you will never need more than n elements, you can use max size vector. Elements are always in line. Okay. The default number of elements in a small vector is usually the number of elements we can already fit in line. Okay, so far this reads very good. This small vector used Forley, Upside, and LLVM as a reference. Okay, that's good. LLVM, they use the small vector as well. Okay, the small string includes all the common optimizations for small vectors and a custom template to set how large we expect the string to be. Okay, in bytes. Yeah. Is this one thing that makes them not small? Is not supporting UTF-8. Small string extra functions. Okay, I don't think we care about UTF-8. Just use ASCII. Okay, so far this reads very good. I think I know this name here. Don't I know this guy? He looks familiar, but I can't recall. This name looks familiar, but maybe it's just some other guy. Yeah. Whoa, he's very active. Lots of greens. Okay, so this looks very promising. Seems to be also quite popular. That's nice. Yeah. C++ small containers. I think we should give this a try. Small. Fetch content. Include fetch. Get properties. Populate small. Okay, let's add it here with fetch content. Okay, so CMake lists, and we go to fetch here, span. So it's fetch content declare. By the way, you can also add a space here. Data, okay. All right. Yeah, let's put a source dir here. Git tag. Origin master. Third party small. Small. Okay, I don't know what this stuff does here. Okay, and then link library to this. Target link libraries. Where do we do it? Target link here. There we go. Okay, let's see if that includes it. Let's see. We're looking at third party, small, please. Small. Yeah. Okay. Includes, small. Detail. Okay. So there's a string, there's a stack, set, queue, map, vector. Wow, the string file is huge. Holy shit. What is in there? It's a 5,000 lines header. Jesus Christ. Jesus Christ. What is this? What is going on here? What is this here? Okay, I would say the formatting is quite wild here. Okay, I think some of the okay, there's also a lot of documentation. Okay, but there's generally a lot of codes. Yeah, an abundance of codes. Yeah. Okay. Okay, that's quite outrageous, I have to say. Okay, so it compiled. That's good. Okay, then let's comment out this one. Actually, I can remove it because it sucks. So let's say include small. Well, wait, hold on. Don't we need to include string.hpp? Probably small. Aha, there we go. Okay, that looks nice. Small string. Okay, let's remove this guy. Okay, and how do we create this guy? Small string. Okay, small string. Then let's go to MGUI app. We go down here. Yeah, let's just create here a small string. And then how do we instantiate that? Basic string. Oof. Oh. Huh. Default inline storage. So we give it a char and then what is default inline storage then? Min reasonable inline vector 5. We rarely want less than 5 elements in a small vector. Okay, 5 is really small. Why 5? Why is this this number? Why 5? Why not 8 or 16? Why 5? I don't understand. Also, what's going on here with the formatting? What is this? What is this formatting here? Stop it. Oh my gosh. That's outrageous. Okay, so I think the default is pretty stupid, isn't it? Default value. Seems pretty stupid. Five. Why 5? Huh. How about we simply put here in our ImGUI app, we put a using stack string equals small string char and then maybe 512. Okay, that somehow doesn't work. Include small string dot hpp. Okay, it still doesn't work. Ah, because string doesn't take templates. So we have to do small basic string. Oh, okay. I wonder if we should put this in our comment types instead. Oh. Comment types. So we have span, stack string. Maybe call it stack string 512. Maybe not. Okay, let's go with this for now. Stack string. Okay, so the idea here, yeah, let's put it here for now, just for tests. Buff2. So, and then buff2 we would assign like a string, right? Like this. Okay, let's see how it looks in debugger. Is there a NatWis for this? Seems not. Okay, so now we have the buff here, and it has inline storage, yeah. And the size is outrageously large for some reason. Okay, so we do buff2 assign, and now it says, we can see it here. Okay. Yeah, inline storage, size 513. So it does +1 for the null char. That's a bit crappy though, isn't it? Well, it kind of makes sense. Yeah. 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 So maybe we should initialize it with 512 minus 1. Yeah. It does have cheap storage here, inline storage. Okay. So we can't see what it's made of. Well, we need to look closely here into the data. Yeah. I guess it's good enough. Yeah. Good. So we have a stack string, and I assume that this will work. That's nice. And we also have other stack versions. So if you want to optimize some other things, we can do that as well. Let's do 512 minus 1 for null char for null terminator. Okay. Okay, then let's try to use the stack string here. So we have the buff here. Buff. Are we really sure that 512 is good enough? What do we store in there? The label. Yeah, I think 512 is. Well, actually, let's go into function.cpp. Function. Here we also use the buffer, and we put 1024. So maybe we should keep it consistent, and here also, yeah. Maybe we should use 1024. Yeah. Okay, let's. 1024 is not much, really. It's not much. Well, it is much, but could be more. Yeah. Okay, then let's make it a bit larger. 1023 minus 1. Okay. Which is quite respectable, I would say. Okay. So. Okay, then let's try to use it. So we have string buff here. And here. Stack string. And here. All right. Good. Buff. Buff. All right. Oops. Buff. Buff. Yeah. Okay. Let's see if that compiles. No, it does. Let's see if that runs as well. It does. And it does very well. Okay, cool. That's very nice. So I would say we go with this one. Let me star this one. Oops. Let's put a star here. It's nice. I don't want to watch it, but don't want to watch it. And let's fork it as well to make sure we have a copy of it. Okay, cool. That looks very promising. Okay, let's search for some more std strings that we can transform to small strings. So, oops. Okay. Oh, we have a lot here. Okay, well, basically anything that is on a hot path. So, yeah, all these are allocated. I think that's fine. Yeah, we just want to when we do temporary processing on like in function strings, basically, right? So that would be in function CPP most likely. So here. I mean, this is a very small string here. Like even std string could almost be enough here for this one. Actually, no, depends on the symbol name. No, this is most likely an allocation. Yeah. Append format. Yeah, we don't want this to be allocations. It's too costly. Okay, so we certainly need to make a pass on all these guys here. We also have this buffer here. This one we can also optimize, which is simply enough. We just make it a stack string instruction buffer, and that's it. Done. Make it here compact. Okay. Instruction buffer. Okay, so then unasm disassemble custom needs to take a stack string as well. Then stack string. All right. Stack string. Right. Okay, so we are looking at instruction buffer. String view. Pseudo simple. Instruction buffer. Okay, here we also have a buff. But this one, wire get line. Oof. Okay, in the ASM printer, we can probably do a lot of optimizations. Let me see. There we probably have some buffers, right? If we can find them. Here we have a dummy. What is that? Okay, that's something else. What is this? Aha. To string. How is this used? To string. It could be a stack buffer, probably. Yeah. Maybe. Okay, well, we need to be careful here, not make any mistakes. Let's do the simple things first. Okay. This can also be a stack string. Yeah. Stack string overlay. Oh, this can also be much shorter. Small basic string char. Probably can be 124, 128, right? And then we do util assign format, and we put overlay. Max size, assign format, resize. Assign format. Okay, so this would clamp. Why don't we have another assign format without the max size? Right. Let me see. Assign format. We remove the max size. And format 2. Format 2. Text iterator. Right. Resize. Okay, so the assign format with a max size that certainly will never over allocate. Would never allocate. Yeah. I think we need to research a bit more on this FMT format 2. Format 2. Oh. Interesting. format 2. As printf is quite slow. Null. Runtime. Printf. I'm still impressed, but that printf is so fast. Oh, it's pretty good. Beating boost. Beating OStream. I would like to see some. Maybe we should ask ChatGPT. But is there like a documentation? Yes. Get started. Building from source. Yeah, okay, so I'm wondering about this guy here, the format 2, back inserter. This will append to out the buffer content can be converted to SC string. Basic memory buffer. Out memory buffer. Okay, interesting. So it's already memory buffer thing, but the question is, where does this live, right? It's probably also on the heap. There's a reserve. Back inserter. Format V format 2. Custom allocators. Yeah, I don't know. I don't know what to think about this format 2. Because of this back inserter. It's weird. It's really weird. Because Format to end does not append a terminating null character. What? Formats args according to specification. Up to n characters. Trans the total non-truncated output size. And the iterator past the end of the output. Does not append a null, terminating null. Okay. So you can place it yourself, which we do here with resize here. This. Returns the total not truncated output size. What does it mean, not truncated? Returns the total not truncated output size. If it returns the size beyond the end of the buffer that we have written to, then this would be quite dangerous, wouldn't it be? Hold on. Oh, that is confusing. FMT format to n. Why is this part of STD? Forwarding the format. Out size. Returns the total not truncated output size. Total. I think this is really confusing. Either this means, I mean, it can't. Format to end result. Total not truncated output size. I wonder if this means that it can really return a result, a value that goes past the end of the buffer to indicate that, hey, you needed this much space, right? Oof. Yeah, in which case this would be wrong here. Maybe we should test this to make sure. Yeah, we can test this. Okay, so this thing was a back inserter. I don't know if that's an efficient way to do this because okay, let's go to our main function. Let's put here tests std string str. Let's do util assign format, and we do percent %s d, yeah, and then we do like a long string, blah 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 blah, and put a number here, long number. Okay, and put the str here, and then put also a max size. So let's say 12, yeah, which is shorter than this junk, right? Okay, let's see what happens. Oh, okay. Includes util.h. Oh. Okay. Hold on. Okay. There we go. Okay, so we have this. Let's go in here. All right. So we resize it to 12 max size, and the result is a crash. Great. Okay. Interesting. Interesting. Report error. What's the error? Message invalid format specified. Oh, okay. What did we do wrong? Oh, right. There we go. Well, that was stupid. Okay, so okay. All right, so size 12. So size, okay. And result size is 32. Aha. So it actually, it does return the size that we would output if we had enough room. Huh. Okay, well then this is a problem, right? Because this assert will hit, yeah. Interesting. Interesting. Okay, then, so documentation is correct, and actually they should have documented differently. They should have put it an exclamation mark, like not truncated, not, I mean, that's quite important, isn't it? Oh boy. Okay, so that means we need to do it differently. Huh. So we have a out EC. So this starts at E0 then, I guess. Watch. Let's do 0. Yeah, E0. Okay. So I do wonder resize. How did they FMT library FMT format to n sample. Okay, I don't know where sample would be, but okay. So it would have to say max size 12. Okay. So we would have to STD distance maybe. Yeah. So what we can do is we do a STD distance result dot out output. God damn it. Oh, I didn't mean to click this button. Stop. Oh boy. So results output begin. Let's put a const size t written distance output begin result out. There we go. And then written is smaller than size, smaller equals size, and then resize written, right? And then here we would have to do the same. Assert written distance. Okay, hold on. distance written sc begin plus start pos. Maybe we should we should do string iterator. Does it take a const one? Begin. Then we pass begin here and here. Max size. And then we say assert there we go. Written result out, distance begin. Okay, this could be correct. Let's see. Okay. Unexpected token begin. Type name. All right. Good. So let's see what it does now. So read out is there. Okay. And written is now 12. Yeah, good. And written is smaller equal than the size. Yeah. And then we resize it again to the same, but that's fine. Yeah. Okay, this will work now. Yeah. Assign format. Okay, it was 12. Yeah. Okay, so this works. So we can write a fixed buffer. Yeah. Fixed buffer. Yeah. Is this good enough for our use cases? Probably. Yeah. Why does format 2n perform so much worse than format 2? That's a good question. Let's see. Format 2 out. Out is this? Format size of out. Result. Let's see what's the difference. Wait, what? Format 2n performs worse than format 2. Okay, that's unexpected. I would have expected the other way around. Hasn't been optimized for format string. Format 2n. Buffering. Still much slower than this. That's surprising. Format 2. I'm confused. Why would this be faster than this? I don't get it. And still, after the optimizations, it's still slower. What the hell? That's strange, isn't it? Format 2 versus format 2 in performance. C++ FMT. Format 2 back inserter. Millions of times, and performance penalty is clearly present. Blah 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 outputs. So he uses back inserter. He's complaining about performance, but yeah. String stream is very bad. Okay. Yeah, I mean, to me, this looks good here. The downside of this is if we pass a max size, and certainly the string can't grow beyond this, which is bad, because what if there is a string that is larger, then we would still like to show it and don't truncate it, right? The string size optimization is only for performance reasons, but not to truncate. So I'm a bit concerned about this assign format. Do we actually use it yet for anything? I think we didn't submit it yet, right? Did we? Oh, we actually did submit it. Oh, oops. Oops. Okay. yeah, anyway, we need to think about how to do this. Yeah. Okay, I will take a break here. It has been almost 2 hours. Yeah, we didn't get much done, but I think we are on the right direction. The small string looks good to me. We need to figure out how we do the formatting thingy. I would expect that the small string and so they don't have any native formatting. They shouldn't. So yeah, we need to figure out how we do it with the FMT. Maybe we do use a back inserter, but I'm a bit concerned about performance penalty of the back inserter. FMT format to back inserter performance. Maybe let's search for std back inserter performance. std insert. Oh, back inserter. Back inserter calls pushback. The problem is with a pushback is if we add every character with a pushback, it needs to check if it needs to test if the capacity is not exceeded. Then it can set the value, and then it needs to increment the size, right? So there's on top of like setting the value, there are this is test and setting the size. So like there's significant overhead on pushback. And back insert iterator pushback. Maybe we should do like a performance test in the next session and see like how expensive this really is. Yeah. Okay, I will take a break here, and I wish you a great day or night. Until next time, goodbye.